Okay, so graphing square roots. First, the basics. So I'm gonna show a function here. So this squared up here indicates this is a parabola. So I'm gonna sketch the graph real quick. So this right here is a parabola, and this is a function that is graphed. But this is not a square root function. So what do we do? First I'm going to show a second example here. So y squared equals x, and this will be graphed right the opposite way. So this is what it looks like. But this is not a function because of the vertical line test. So what do we do? In order to turn this into a function, we need to square root both sides, and the product would be y equals square root of x. Now we finally got the function for square roots. Okay, so now I'm going to graph this. But before I graph this function, I'm quickly going to show this graph. So this graph will be something like this. But since it's a square root, not so. This is squared. We got this. So since this is a square root, it's half of this. Therefore, we only get one side. In this case, this will be a positive side. Nevertheless, let's continue. So how to graph this? Okay, so first I'm going to find the domain. I'm going to start by doing the following. 3x plus 2 is greater or equal to 0. This is so I can exclude the domain. So this will be my domain. So I subtract 2 from both sides, and I get 3x is greater or equal to negative 2. Then I divide everything by 3, and I get x is greater or equal to negative 2/3. So right now my domain is the following. So D for domain, and my domain is greater or equal to negative 2/3. So now I have the domain, and it's time for me to find the range. So what should I do? Okay, so let me put here the domain and the range. So how would this work? Well, since this is equal to or greater, I can use 2/3 as my points. On a side note, if this is only the domains greater than 2/3, I wouldn't be able to use this. I would have to use something greater. So negative 1/3 or 0 or 1, but not negative 2/3. Nevertheless, let's continue. So let me just write here my equation, which is, y is greater than 2, 3x plus 2. This is all square rooted. Okay, so what do we do now in order to find the range? All we do is pretty simple. We plug in the domain into the equation. So what will happen will be the following. And now I substitute the x for my domain. So I put parentheses, 2/3 plus 2, and this is pretty simple. So 3 times 3, so these 2 would cancel out, and I would have square root of negative 2 plus 2. Okay, so as you all can see now, this is what I have, and my end result is just 0 because this is nothing. This cannot happen, so 0. And so I go back here and I say 0. So what does this mean? Well, when my domain is negative 2/3, my range will be 0. So I have my first point. Then I'll do something greater than negative 2/3. Okay, so for the sake of time I have sped up the work, and now I have all my points. From my last video you can get the idea of how this is all done. And now that I have my points, I would advise you getting 4 to 5 points. I got 6 myself, just to make sure. And now all I have to do is pretty simple. I made here a quick graph, and now I just have to plug these points into this graph. So let's begin. So negative 2/3 2 over 3x. This is my domain, or my x-axis. So what I do, this is not really precise, but let's say it's about here, because my y is 0, so it goes 0 up and negative 2/3 back. My second point is 0x, so it's right here, but I go up 2 and 83, so 1, 2, and almost all the way up to 3, so about here. The next I go 1 to the side and 4.5 up, so 1, 2, 3, 4.5, so here I am. The next one I go 2 to the sides and 5.5, so this is 4, so 5.5 up. Next point, so this is 3, 6, so if this is 5.5, that's 6 and almost a half, so 5, 6 and almost a half. Now 5, so 1, 2, 3, 4, 5 and 8 up. So we go 1, 2, 3, 4, 5, 6, sorry, 1, 2, 3, 4, 5, 6, 7, 8. So weight is about here. And now all you have to do is just connect this line. So here we go. This is not a straight line, this is a curved line. Mine's actually pretty curved. And this is it. You have now graphed the line. Congratulations.